Good morning, all. Today, our topic is electrochemistry. So, electrochemistry is an important branch in chemistry, and a lot of importance is given to this electrochemistry. Let us see why one need to learn about electrochemistry first. Let us take one or two examples. Women love gold. Gold is a precious metal. How gold is obtained? When you dug earth, you get a number of rocks. Of these rocks, certain rocks contain gold in higher proportion. These are called as minerals. From these minerals, by metallurgical extraction, we extract gold. Even though the gold is extracted, its purity is not good. So, in order to improve its purity, it is allowed for a process called as electrolysis process. So, it is an electrolytic purification. Most of us use mobiles. The mobile operates with the help of a battery. When we use the mobile continuously, the battery gets discharged, and when the battery exhausts, when we connect it to the electrical port, the battery gets recharged. So these two processes also involve chemical reactions. So chemical compounds are involved. Chemicals produce electricity, or electricity can be used to convert chemical compounds. That is the reason why electrochemistry is a very important branch of chemistry. After completion of this class, what the student can be able to do? The students can be able to define the basic terms in electrochemistry, and they can give some examples for the conductors and insulators. So our main focus is about the basic terms in electrochemistry. Let us start our lesson. Electrochemistry is the interconversion of electrical energy into chemical energy and chemical energy into electrical energy. I told you, you supply electricity, the purity of gold increases. Gold associated with a number of other impurities means various chemical compounds. All those chemical compounds are removed, the purity of gold is increased. So, electrical energy is used to produce a highly pure chemical compound. The second one, when the battery gets discharged, we connect the charger to the electrical power. Then the chemical compounds will transform into electrical energy so that we can reuse the battery. So this interconversion, the study of these interconversions, it is called as electrochemistry. Now, there is an important point here. That is, so if you want to convert a chemical compound into another form, you should supply electricity. So there should be a chemical compound that should be able to conduct electricity, that should allow electric current to pass through them. We, from our basic knowledge, already know that there are a few chemical compounds which do not allow electrical conductance to pass through them. So, based on their ability to conduct electricity, chemical compounds are classified into two categories. The first one is called as a conductor. So, what are conductors? Electrical conductors are those substances which allow electric current to pass through them. You supply electricity from one end, to the other end you can get the electricity. So these are called as electrical conductors. So what are the examples for electrical conductors? Most of us know most of the metals means copper, aluminium, silver, gold, all these are very good electrical conductors. Of course, we don't use the precious metals, but we use a metal like aluminium or copper most commonly. Alloys. A combination of more than one metal is called as an alloy. At times, a metal and non-metal is also called as a alloy. So, in order to reduce cost, to improve certain properties, some metals are mixed. Since metals are conducting in nature, the alloys are also good conductors like brass. So nickel, monomer metal, etc., are used as electrical conductors. The other one is graphite. Interestingly, graphite is a non-metal, but it is a very good conductor of electricity. The ionic compounds. Ionic compounds are mostly solids due to strong electrostatic force of attraction. These solids do not conduct electricity, but when these solids melt, these ionic compounds have a tendency to absorb water. So they gradually transform into a liquid. These ionic compounds, when heated, they transform into fused state. So they can conduct electricity. Ionic compounds added to water dissolve. They produce ions. These ions also, due to the mobility towards the oppositely charged electrodes. That means, uh, unless you supply electricity, you cannot differentiate between a conductor and a non-conductor. You should supply electricity. That means in ionic compounds, with the help of a conductor, if you supply electricity, then these ions will move towards the oppositely charged electrodes, which are called as cathode and anode. The next one is insulator. Insulators are those substances which do not allow electric current to pass them. Take a solid. You supply some electricity, but you cannot absorb the current passed from the other end. So these are called as insulators. They do not allow electricity to pass through them. Examples. The classical example for electrical insulator is rubber. Yes, most of these electricals are covered with either a plastic or a rubber coating. Similarly, glass, a very good insulating medium. Wood is a highly non-conducting medium. So these electrical switches are embedded in the wood, and that is made into a beautiful. It will give you a good aesthetic look. Similarly, paper, most of the organic compounds. Organic compounds are covalent in character. That is the reason why they do not conduct electricity. But organic compounds which are ionic in nature, they can conduct electricity. So this is about the chemical compounds and their classification into conductors and insulators based on their ability to conduct electricity. Let us move on to the next one. Types of conductors. So if you remember, I just told you, in conductors there are two types based on their physical state. Metals in their solid state can allow electrons to pass through them from one end to the other. Ionic compounds in the liquid state can conduct electricity due to the movement of ions under applied electric field towards oppositely charged electrodes. So based on this, the conductors have been classified into metallic conductors, and the other one is called as electrolytic conduction. Let us have a look at the metallic conductors. So what are metallic conductors? Solids which conduct electricity due to the flow or movement of electrons from one end to the other. They are called as metallic conductors. We have already have a look at these examples: metals, silver, copper, gold, aluminium, everything, graphite, the non-metal, and most of the alloys they are conducting in nature. The next one is electrolytic conductor. Ionic compounds are covalent compounds with ionic character. When added to water, they give rise to an aqueous solution. These aqueous solutions are in fused state. The solids melt to give rise to fused state. When electric field applied, these ions will move towards oppositely charged electrodes. So the substance whose aqueous solution or fused state conduct electricity due to the movement of ions accompanied by chemical decomposition. There is a change in the chemical form also. If you remember, when you supply electricity, what happened? Recharge of battery takes place, right? So the examples are molten sodium chloride, aqueous copper sulfate. The most of the acids, they are directly liquids, they can conduct electricity. Acids added to water, alkalis or bases, they can conduct electricity either in their fused state or their aqueous solutions, etc. Thank you.